All right, we are going to go ahead and continue on with where we last left off. Do something here. Okay. So we were working on, oh, that's nice. It brought me right back to this. So this is divide, and I have a plan for this. All right. So we're on divide. All right. So basically, we're going to do the subtraction method on this. So what I need to do is a couple things. All right, so I'm gonna do a couple of things here. So I'm gonna set up some constants. Am I? Yeah, just so I can keep track of, or so I don't lose track, more like it. Actually, I'll just do inFs. Actually, let's do. All right. So we got those. Now, so a couple of, let's see, and then immediate add. All right, so add I1 or add I0. Now I'm trying to think here. I know what I want to do. I just not thinking if. Actually, let me bring up my command sheet list as well. All right, so put these on here. I can get rid of that, and I can get rid of that. Move that over here. All right, so grab that one. And we put this here. Oh, I shouldn't need these commands. All right, so now 64. I could have swore. I have to go back and look at this now. Conditions, immediate values. I could have swore. Oops. Eighth bit, argument 1. All right, so let me go back to, yeah, so I mean, that's right. Is divide? Yeah. So when we do an immediate with this, the 8th bit, it's supposed to take argument 1. So why do we have, why did I do that? Excuse me, for the life of me, I cannot remember. Let's go back and, so 64 on the opcode. Will, let's see what the first one does. All right, so I broke something there with 64. Register 0 should have a value of 9, not 7. Because my input. Yeah, how did I get those? Now I'm scratching my head. Because 64 is supposed to pull from this register. How did I get those backwards? When did they get backwards? Because this here, the toggle byte switch, the default with nothing being pushed is this bottom one, I think, right? Yeah, so with no output, or with this off, it goes out the bottom. Yeah, so that's right. When did I change that? I don't remember changing that. Okay, so that makes a little bit more sense. Okay, so because that should still pass to do what it's doing, which is basically pulling input. Okay. Yeah, so somehow maybe when I was cleaning up some stuff, I just reconnected them incorrectly. Because and you know what, let's do this. arg1 immediate and arg2 immediate. All right, just so I can, because by at least seeing this, I'll be able to, do it or understand what's going on there. Because, in my mind, initially, or at least not in my mind, but to me, a common sense approach would be have 64 or have the 7th bit here trigger argument 1 and 128 trigger argument 2, not the other way around. Okay, so when we do an immediate, it basically stops the value for that respective register from passing on to the respective switch to trigger an input pull or save as a word, depending on the situation, and that passes that to its respective output. So that's how I can put an immediate value into a what you call it. You know, I can force something here. Now I can't do programming here, but I can go to the sandbox. This is where the sandbox comes into play. Which one is the sandbox? So on the sandbox, that change should have taken effect, right? So in the sandbox, if I do a 192, which is essentially a 64 and a 128, and I do say 4 and 6 to 0, I should get 10 in 0, right? Oops. Okay, because it's literally taking the two numbers that I'm plugging in. All right, so that's good. That's what I wanted to see, or one of the things I wanted to test out. All right, so all right, back to divide. All right, so a couple of things, let me go ahead and get that. All right, so we need to take input, put it into register, register 1. So the way we can do that is we can do an immediate on either register. So we'll do register 1. So register 1 will be a 0, so that, because essentially we just want to do a flat copy, so we do that, and then we do 7, and then we do 0, or we can do R0 as it were, and we can do in. Okay, so and let's do this. M1 will be 128, M2 will be 64, and then M12 will be 192. So oops, those will be constants. As well. All right, so first thing we're going to do is an immediate one. From input to register 0, and you know what we're going to do here? We're also going to do this. All right, so basically what we're doing is immediate one will so it will have a null value 7 to there. Then on the second pass we'll do another M1 null in R1. All right, so that will load. Let's go ahead and move over so we can see the actually we can see the registers here. So first pass 193, second pass 57. All right, so now we need to do our so this is the initial load. All right, so now let me just put a comment here. Okay, that's the initial load of what are the terms I used? I can't for the life of me remember. Numerator and denominator. I'll just do that. Now here's something else I'll do. Numerator numerator will be in 0, and denominator. Is that how we spell it? I can't think. Denominator. Okay, cool. Denominator will be in 1 for locations. Oops. The quotient quotient, I'm going to put that in 2, and the remainder, so the remainder aspect, it will, I don't really need a look. The remainder will be in 3. All right. So now this is the initial load. Once the load is done, we need to do a, because it's possible. I don't think that ever actually would happen. And what I'm thinking is, they should never, in this, because we're not dealing with fractions, as it were, they should never ever, well, actually, you never know. They could give me a numerator that's less than the denominator, which technically would be the remainder with the quotient of 0. So we need to do a less than check at the start just to do it. So a less than check is, we need to check values here. So we need to do a 34, which is less than. So let's go ahead and put that less than is 34. All right, so we need to do a less than, and we need to do now numerator, denominator. So if it's true, then we need to say where it's going. We'll call it end. End is going to be a label. Now, the one thing it doesn't say is what it expects as an output. I presume it expects 2 outputs, one being the quotient, one being the remainder. Now, end has got to be at the end. So the end is going to be so label end. So on label end, it's going to be essentially a copy. So a copy is a 0 because it's basically a copy is an add with a 0 value. So So basically, we're gonna copy quotient first, quotient null out, and then copy remainder null out. So that's the end. But now this here is on the first pass, obviously it's not going to go through. So now we're going to do a label minus. Okay, and what's going to happen is we're going to let me do a constant for add. Constant of add will be 0. Constant for subtract will be 1. So we're basically going to subtract sub numerator denominator, and we're putting them into the remainder register, because okay, so we're going to do that. So then as soon as we do that, so because I'm using registers 0, 1, 2, and 3, the quotient is going to I need to have a static, and so we actually will do this also. Immediate 1 null, it's going to be so I want to do an immediate 12 of a 1 null to, we're going to put it in R5. That one there is going to be used for adding quotients. Okay, so when that happens, then we're going to do an add. Actually, it'll be, because it is an add function. All right, something I haven't tested yet. So, well, you know what? We're going to do a test right here at the top to see what happens. So if I do an immediate 12, 0, 1, or immediate 12, so 1, and we put that in 0 just for sake of argument. And then if we do an add, if I put 1, 1, or actually, I'm sorry. If we add, if I do an add 0, 0, trying to think how I want to do this. So actually, no. So if we do an immediate 1 with a 0, 0, and 0, I'll be taking 0 out of the register or out of the program, adding it to what value is in 0. That should get, what am I trying to do here? You know, let me just see what this does. I have a feeling I know what this does. There's something I'm trying to do, I just can't think of how I want to. Yeah, so that did, did exactly what I thought it would do. All right. Okay, so going on the premise that the because okay, so let me try this just out of curiosity. Immediate 12 of 1 0 into 0. That'll put a 1 up there. Immediate 12 of 1 0 and 5. And then if I do an add, 0 5 into 0. What I'm curious is will it, if my source on an add is also my destination for an add, what happens? All right, so we get 1 there, we get 1 there, so we do this. Okay, so it does add up. Okay, all right, so that's what I wanted to see. So if I do that again, okay, that works perfectly. Okay, cool. That's the one thing I just wasn't 100% sure on with respects to whatchamacallit. So we need to, after we do the subtraction, we need to do the denominator. So we're going to add quotient, which is 0. I can spell. Add quotient. Now I'm going to store it in register 5. So register 5. The shortcut for that will also be we'll call it fix 1. Fix 1 will be in 5 as well. So quotient fix 1 to quotient. So basically, at the start, the quotient will be at 0. It's going to do its first subtraction. It's going to basically take 0 plus 1, put it back into the quotient slot, so that should become 1. Then we need to do another lesson check. Which, if it's good, then it'll go to the end. If it's not good, then we're going to move remainder. Oops. So for that, we're going to do a copy remainder. null to numerator. Not numerator, numerator. All right, because copy is basically a 0. So if we do a copy, add null. So you have to have a null in there. No, hold on. So no, null won't work in this. You can't do an immediate. Actually, you could do an immediate. Actually, so that's what we're gonna do. We're not gonna do a copy. We'll do immediate 1 null. Remainder to numerator. So what that should do is that will take the remainder, put it into the numerator slot. And then we rinse and repeat. So then now we got to update the counter to jump back to 16. So in order to do that, we do an immediate 2. No. Yeah, immediate 2. Hold on. Null minus counter. So immediate 2, no, sorry, immediate 12. We'll send a 0 value out to the add. So it'll take 16 plus 0, so 16, and it'll send 16 to the counter. I think that will do it. Copy won't work. Now that I think about it, copy won't work because this null here. So what we do is, so this will be an immediate 1 and an immediate 1. Because immediate 1 is 128, right? Yeah. All right, so let's get rid of copy because copy ain't gonna do shit for us. Because in order to copy, excuse me, you need to essentially do an immediate 1 with a null, then the stuff. All right, so I think. All right, so let's look at this again. All right, so we first load our numerator into register 0, our denominator into register 1, and then in register 5, down at the very bottom, we're going to just put a number 1. Then we're going to do a quick check to see if a less than numerator is that. So when we do a less than, which is a 34, right? So when we do a 34, this here will activate and we'll take we should see 193 on purple, 57 on whatever the hell that color is. It's going to be false, so this won't activate, and as a result we're not going to jump to the end. Well, now here's the thing is, yeah, because end will go on, okay, so here's the thing is, if that's true, so, because end is going to be orange. Oh, but I have a switch here when 32 is active. Orange will then get piped on to this. Okay, so, okay, that's why we did that. So then, because this is just a quick check, this should never occur, because I don't necessarily see them giving me a quotient and a whatchamacallit, or giving me, you know, let's say 19 divided by 57. You know, I don't ever see them doing that. So then, now, here's the deal. If this is true, then we go to the end. Okay. No, actually, so if this is true, then this is going to be numerator. Because, oh, damn it. Hold on here, hold on. Okay. All right, so if this is true, this is going to go to end one. End one is basically going to do immediate one, null, numerator, stop doing number, numerator to remainder. And then we go to end. Oh wait, then we do then we do then we do an immediate so how do I so immediate 12 null end counter. All right, so what's going to happen is if this is true, then we need to move the numerator to the remainder slot, and then we jump up to here so we can output that. That won't never be true, so it should never technically come down this far. So then the normal path, which should loop a couple times depending on how big and small the numbers are, we're gonna do a subtraction, this minus this, that will go to the remainder slot. Then we're going to add a quotient because we did one divide action, you know, quote unquote divide action. We're going to check to see if, no, we're not checking to see if the numerators, we need to check to see if the remainder is less than the denominator, because at this point in time, this will still be a 193. So we need to check to see if this number here is less than this. If it is, then we go to the end. If it's not, then we're going to move the value from here up to here. And then we're going to basically send something to the counter to basically jump us back here. And we're basically just rinsing and repeating that until this is true. At the point, okay, I think, therefore I am, that this will work. All right, let's find out, shall we? So, I wish I could change the what do you call them here? Change the name of these. You know, change it so I could see what's going on here. All right, so what watches do we have? I added extra watches just because. So 7 goes to the hell 7 go to? 7's out. Okay, so 8, 9, 10, and 11 I can take. I can get rid of. I think 8, 9, 10, 11 we're all going to the ALU thing. So oops. Let's go ahead and get rid of those. Oops. So 8, 9, 10, and 11. All right. So let's see what happens here. So step 1. We got that number. Step 2, we got that number. Step 3, gonna put number down there. Now we're gonna compare. So on the next step, we should see this. So purple and blue. We should see 193 on purple and that one on blue. It didn't meet the requirement. So now we're going to do subtraction. So now what we should see is, let's do some math here. So 193 minus 57. We should see 136 appear here. Or there. You know what? That's fine that it appeared there, as long as it's consistent. Okay. And then this should turn into 1, which it did. All right. Now we're going to do a check to see if 136 is less than 57. So go up here. 136, 57, it is not. So because it is not, we're going to move 136 up here. Okay. And then we should see a 16 going out on this to change our where we're at on the counter, which we do. And now we rinse and repeat. So now we're gonna subtract 136 from 57. So let's do another minus 57 here. So that's going to give us 79. 79 should appear down here now. It did. We're going to do the lesson check. So 79 is not less than 57, but we should see. Oh no, I'm sorry. We're doing the quote and add first. So add 2 there. Now we'll do the lesson check. Okay, it is false. So now we're going to move 79 from here up to there. Boom. And then we're going to reset the counter again. So we should see 16 going out on that. All right, so now 79 minus 57 is 22, which is technically our remainder. So we're going to subtract 79 from 57. Where's my... So subtract 79 from 57. We should see 22 appear here. There's our 22. Okay, so now this should be true. So Oh, sorry, we got to do our quotient. Yeah, so we're adding our quotient. There's our quotient is right there. So now we do this. It's true. So now we're going to send the end, which is 36, and there's our 36. Now, this is the part I don't know because it's not very clear. I'm pushing, well, 36, that's not activated yet. So I'm going to send it 3, and then I'm going to send it 22. Okay, so that's how I wanted it to work. Okay, so I'm fairly confident this is going to work. It takes some time to do this, unfortunately, but I did it. I'm proud of myself on that one. All right, now what do we got here? So RAM. Yeah, I'll give you some RAM. Add a RAM block so the computer can address 256 additional bytes of memory. You need a way to decide which of the 256 bytes inside the RAM we are addressing. Select a register and wire it up so its value always selects the RAM address. When you later want to load or save to the RAM, you have to first copy the RAM address. In this test, first copy from input 32 times and store these values. After you've loaded the 32 values, output them in the same order as you got them. Outputting before you have read all the inputs will fail the level. Okay. So, it said add RAM. So there's RAM. So in this level, the RAM has a load, a save, address, save value, and an output. So we want to load 32 times. Okay. And then once after the 32nd has been loaded, then we want to output this, which is going to be interesting. So essentially, I'm going to need a new, maybe 8. I don't think I'm using, I'm doing an 8 here. All right, so we're going to be taking from the input here. So that's easy enough to do. I can pipe this up here. Now, let me take a look at something here. What is my disable bit on this? My disable bit on this is, okay, so if I send an 8, I'm disabling this, which is actually fine. Actually, that could work to my advantage. If I always am going to load the RAM from the input. But if I'm going to load the RAM based on 2 added values, well, no, that could technically trying to think here, because on this puzzle we're loading straight from input, so that's easy in the sense that as far as I can just take this input line, feed it up to here. And all right, so or well, so as far as addresses are concerned, because this here is opcode. All right, so if we're going to copy, I mean, do we copy directly into the RAM? Because it's talking about select a register, wire it up so its value always selects the RAM address. Oh, okay. So that's talking about the address. You'll need a way to decide which of the 250. Okay, so you'll need a way to decide which of the 256 bytes inside the RAM we are addressing. Select a register and wire it up so its value always selects the RAM address. When you later want to load RAM or save to the RAM, you have to first copy the RAM address to this register. In this test, first copy from the input 32 times and store these values. After you have loaded the 32 values, output them in the same order as you got them. So to me, I'm just going to use a counter, I think, to do the load. And then essentially reset the counter on the offload. But now, using the existing architecture, what opcode, or how would I want to do this? So, if we do, let's say, an immediate, input to register 0 here. And so we're going to need some sort of counter mechanism. I mean, we got a counter up here, but that counter there is, pretty much for this program here. I don't want to use this to, because this is going in increments of 4. So we'll need some sort of, where's my counter at? Got a clock. All right, so I'm gonna need a counter. And no signal here. Let's move you down here just for the time being so you're out of the way. And we're gonna need depending on the opcode is either going to be load to RAM or or save to the RAM or load from the RAM. Now the address, so the counter is going to be the address function. At least that's the way I'm looking at it. So that'll be my counter. Now, as far as the load or save, that will be based on the opcode that I'm going to use. So, and also, am I going to come directly off input, or am I going to take it off of purple here? Because if I take it off of purple here, it's going to be a matter of doing an immediate off of this to a register, and then the second command will take it from the register and because I don't want to use, I can't use address 8. Because I'm using 8 on this as a disable. And let's see, as far as, I could do, for my disable, let's do 24. So we'll use 24 as our disable for math. All right, yeah, so we'll use 24 as our disable. So let's go ahead and change this from 8 to 24 to disable the math. So we'll use this save value. We'll put our equal checker on there. So we'll do an equal checker and a switch. All right, so the equal checker is going to trigger that. That in turn will trigger that. So when we load the RAM up, I'm thinking we're going to do so like when we do an immediate, so if we do an immediate 12 as an example, no, we'll do immediate 1, excuse me. We do an immediate 1, null 7 8, which immediate 1 null 7 8 will basically take the input from input. They'll go through its math functions here, and 8 will go out on so immediate here, so that's going to be essentially a 0. I'm sorry, it'll be a 64, or no, 128. So it'll be a 128 on this line here. Null will be here, so we'll just put a 0 on this line. On the output line, 7 will be on this line, which will pull from the input. Then that will go into the adding machine. We put an 8 on this line here. So basically, so we're gonna pull from here just because. Here's another question: do we want to have this up higher or down lower. Because I gotta take in consideration of, I don't know, other things that are going to occur with this. Let's move this RAM here for the moment, just and we can clean it up after the fact. So we're gonna take this, and just for the time being, we're gonna go ahead and just take it wide. We'll well, that's perfect. All right, so then orange, which is our destination, we need to feed orange. Okay, so I need a constant. Give me a constant. Where's my constant at? All right, so one constant, this will be 8. Okay, that constant will feed onto that, and then we're going to take this orange here and essentially tie it down here. I'm going to just go like this just to give room for this counter mechanic. Okay, so if we get an 8 here, it'll activate the switch to store. Now so this is the storage function. So if this is true, then we also want this to be true, which is the save function. So if we're loading, so let's do this. Let's slide you back a little bit. And let's, I'm gonna put the counter up here just so I'm not, what? All right, so this here will be the storage function. All right, oops. All right, so now as far as the counter function is concerned, this is going to be the interesting one here. Well, no, I mean, we're going to load 32 times. So we need a counter to increment on every load. So they actually should, oh wait, I have to program this up. So let me see here, just, it's not going to do anything, obviously, right? Actually, what did it say? Next counter value 4 is not the start. Oh, yeah, because that's empty. I haven't programmed it up yet. All right, so the counter by default is going to, increment 1, 2, 3, 4, blah, 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 blah. Because increment by 1. Now, what's going to be, okay, so, all right, so, all right, so now I'm thinking about using 8 as my, well, actually, so 8 and 9, opcode 8 being load 2, opcode 9. Let's do that. 8 will be, I'm sorry, save to RAM, and 9 will be load from RAM. But now, so actually, we're not going to use a counter. Nope. So we are going to have a special register, or pair of registers perhaps. Because what's going to happen is the register, which will be, this is, so we have a, so we'll put a register. Let me just get a register real quick. That's a counter. Where's my registers at? There it is. So we put a register in here that we will, so that means I've got to address this as something else. So address number 9, I guess, maybe. Man, this is gonna be a pain in the butt. All right, so this is gonna be my address register. Taking them. So now I could all right. Let me get some more drink here. Let me think about how I want to do this. So we'll be back in just a moment. Sorry, 1 second. Something's acting up here. All right, so we're gonna get rid of the counter. The register is going to feed, oops, the register is going to feed this, the address. But I need a mechanism of checking what's in the register to know when we've hit our 32 or whatever limit, you know, we're going for, so that we know to essentially reset the register to, you know, 0 for the push. Okay, let's do this for start. Let's just do a test here on a load. Just to load one number into it. So we'll do, and if, all right, let me go to the previous level, which was this one here. Let me grab my program, not the program per se, but grab this part, at least up to there. Let me copy that just because. And also, let me put that on a cheat sheet so I can copy to it later, or copy from it later. All right, so we're going to do, and so let's go ahead and paste this in here. Constant RAM is 8, and we'll do a constant RAM reg is 9. Okay, so we're going to do an immediate 1 null 7 input to 8. Okay, the register is right now pushing out 0, so that should, you know, we should see whatever the input is appearing there. Okay, so that is what came out of 1. Okay, good. So then the next step that would happen is this register would have to increment 1. So we're gonna make that 9. All right, so we're gonna basically do something like this. And we'll put it, let's say, right there. Or actually, let's put it a little bit lower, just so I can have access to the other switches there. Because it's going to tie into the same thing here. This will be 9. All right, go ahead and extend you over. Now, this here is just, oh wait, actually no, I want this up higher because this is the trigger mechanism. Okay, let's move you over just so I have some room here. All right, that's fine. So but now what's going to be my register load? Or, you know, what's going to be the register load, not the RAM, because 8 will be, actually, no, sorry, that's going to be 10. 10 is going to be the register beat. So 10 will be register, save to register, and 11 will be load from register. All right. Man. So let me go ahead and get 2 more of these. So just go ahead and put you there and put you there. So this one here will be 9. We got our 10. This one here will be 11. All right. So 9 is going to be the trigger to push from the register. So the load. Okay. Go ahead and make you yellow just because. All right. And then go ahead. Do that. And go ahead and do that. All right. So 10. Let's go ahead and move you guys up. Okay. Just because. Because 11 will be up this. Okay, move you down 1. Okay, so 10 is loading to the register, and then 11 will be loading from the register. So I'm actually going to do this, this, and this. All right, so yeah, let's go ahead and do this, this. Slide you over some. We can compact this just a hair here. Oops. Come on. All right. And then we can move you over. There. Okay. All right. So, and actually go ahead just because. All right, now as far as getting data to the register, that is going to be, well, that's easy because that's going to come on this line here. So I can basically just feed this up into here. All right. All right, so 10 is a load to the register. So let's do a test here. Immediate 1. Okay, so we added a number to the register. Then we do a null. Oh, no. 1, 10. No, wait, null. Yeah, 10, 10. So, because the register currently, the register currently has a value of 0, this should increment it. Let's see what happens here. Good. So now, the next address it goes to should be 1. So, in theory, let's see what happens here. It didn't change. Why didn't? Oh, because I got to trigger. Oh, because I got to do I know why. So then we need to do immediate 1 null 11. There we go. No. Wait, did it reset? Hold on. Why did it reset? Hold on. Wait. Something ain't right here. This is my load, which changed the address. So we changed the address, but as soon as I take that 11 off, so okay, you know what? I think I see what I need to do here. All right, so I don't need 11. Because technically 8 can do this for me. So, god damn it. And what I mean is, actually 8 and 9. Well, no, so 10 has to be independent. So what we do is we tie 8, I think. Well, 8 and 9. Because when we want to do a push from an address, but now here's what we got to do is we got to make sure this is just a normal thing. So what we're going to do here, as crazy as this seems, I'm going to put a buffer here, put a buffer there. And now we're going to move this stuff back again. Actually, moved it forward. Okay, so just give myself just a little bit of room here, so I can have some room. That's good. Go ahead and put it back to where I had it on the edge. Okay, so what we're going to do here is basically we're going to take 8, tie it into this, 9, tie it into this. This way we can tie these together here and do that. And so what's going to happen here, what's going to happen here is on a load to RAM, on a save to RAM or load to RAM, it's going to activate the register simultaneously for the address. Now, by default, at the very beginning, this is 0, so that's fine. So no issues there. Now we increment the RAM or increment the register, and now, aha! All right, I'm happy now. Okay, so then we could rinse and repeat this let's see, now I got to do a check because we need to do this 32 times. So technically 31. So when the counter hits, when this hits 31, we need to, so then what we got to do, all right, so actually, so let's just call this label load RAM. Okay. And then after it does its load, after it does its load, we need to do a comparison check to see if it equals 31. So hold on. So we do our load. No, hold on. So we need to check beforehand if it equals 31. Because I need to check here if it equals 31. All right, so what we got to do is, how do we do a comparative check? Well, we're not using 11, so we'll use 11 to check register. How about that? So 11 will be check register. And so how we're going to do this, so we close that, we're going to get our equal. All right. And so actually, I don't know why I just didn't do this. We're going to do this. And basically, ironically, we're putting it right back to where it was previously. We're going to make this 11. 11 is basically going to tap into this. And then we're going to do, because we need this to be activated in order to push out a signal. Then we're going to put on a constant, what I say, 31. So 31 will be that, and that. All right. So then we're going to do another equal. So we'll just put you right there, put you up here, put you here. Now, if this is equal, this is basically, actually, so no, well, we need to treat this as a 32. Or we need, we need to, okay. Because what I need to do is I need to do if equal. So basically, if 32, if this is equal to I'm trying to think here if there's how I can do this, because this here will trigger this. So I should just use the if. I should just use this here. Easy solution. Maybe. So these are going to be pushing zeros, right? Because I won't be kicking anything out from these. So if I do a 32, it's going to look, it's going to basically pull this in here. Normally on a 32, you would trigger a, hold on. So on a 32, we stop the opcode. We send a 24 so it doesn't do any math. All right. These will continue to go to where they're going. But if let's see, here's the thing is I can't do null values. Technically I can use 8, 9, 10, or 11 as just a generic see the thing is, so I don't want to, I mean, I could, like I said, I could push 11 or 12 or something like that, because that won't trigger any of these. So, or I could just do 255. You know, I could use any high number on these arguments, because it's going to pull here. So what we do is okay, so to check the register, even though it technically doesn't matter, well, no, because we need to do 11. So it's going to be if equal, so it'll be 34, high number, 11. What's going to happen is we're going to put the register on like here and the constant 31 on here. This will be tied to a switch. It's tied to this. All right, so it's definitely not super efficient, but we're going to go with it. All right, so, but, yeah, so we're going to need actually two switches. Oops, because I don't want this getting hit with a number, getting hit with this number prematurely. Yeah, so when we do the if check, that's the only time this should pass values up. Because when we're doing the load, because hold on. Because if we're doing a load, which is a push from the register, that's going to trigger this. Hold on here a second. Well, actually, so here's the thing is, if we're doing a load to a register normally, in this situation, if we're loading to this on a command line, it's going to be like an immediate yeah, so if I do an immediate value, you know, whatever to say, 11, if these activate and I have them on this, then it's gonna unless I do a byte buffer, you know, so if I have a byte buffer going this, no, it's gotta be a, so how do we Oh wait. Okay. I think I got an idea. So it is a byte buffer that we want. We put a byte buffer here. No. Okay, I need some more room to do this madness plan that I have. All right, so let's go ahead and move these over. Okay. So we're going to put a byte buffer, bit buffer here. Okay. And then we're going to tap up from here to hit this switch. And this switch. So what will happen is when 11 is activated, it will activate this, so we can do the comparisons. But when the load or read to the RAM turns on to activate the register, it won't activate these. Okay, so that's good. And so then it doesn't matter which one which one they go on. So we'll go ahead and put tie purple into the low one, and we'll make this blue one here go into this. Okay, so if we put, let's go ahead and just program this up, do a test here. So let's do, just for sake of argument, an immediate one null 31 to 10. That will set the value of the register to 10, or set the register to a value of 31. And then if I do a less than, which is a 34, equal, I want equal. So if I do a 32, some high number, 11. Well, now here's the kicker. Hold on. Because the whole point of this less than is this is going to cause a jump. So I need to, hold on, let me think on this one. 11, I actually need to tie to one of these. Doesn't matter which one, but I need to put 11, or I need, so if I put, well, and that's the good thing, is if I put 11 on one of these, it's not going to hurt nothing, because, so I need to put 11 on one of these. My output is going to be the loop back function. I don't know why. So this here is going to be the loop to end, and or go from the load to the unload. And so then the unload, so label unload. So actually, so if it's okay, so if it's equal, it's going to go to load or unload. Because if it's not equal, so if it's not equal, okay, so this is going to load. Actually, let's call it, if it's equal, it goes to unload. If it's not equal, so not equal is a 33. We'll just do 255 for the minute. Go to load RAM. Okay. If it's equal, then what we got to do is we got to reset the register. So to reset the register, we do an immediate one, null 0 to 10. That will reset the, or I could do null to 10, either one. Null and 0, imagine that, they're the same thing. So null 10, that will reset the register. Then we do an immediate one of null, and in this case we're doing a 9, that's a to 7. So this is actually not correct anymore. This is RAM load. This is, I'm sorry, this is RAM save. No, wait. Yeah, RAM save. RAM load. And then constant RAM reg. Save is 10. Constant RAM reg. And so I don't, 11 is only used to check. So RAM reg check is 11. Because on the load and save functions, it's automatically going to turn on the register. So it's just on the save. Okay. So let me see if this. All right. So on the unload, we're basically going to reset the register with 0. Then we're going to do 9 to 7. So what I got to do is I got to get, basically loop this over to this. Wait. Hold on. Why? Oh yeah, because I need this here for the overwrite. So in theory, a whole bunch of theories going on here. Is this gonna give me feedback? No. Yeah, it did. You message. I gotta figure out a way of taking this output so I guess perhaps I could put it on one of the lines. So if I take this and let's say put this on, well, it's got to be on magenta in order to so do I need am I gonna have to do a switch activation? Oh, you know what we could do? Maybe. No, that won't work. I'm trying to think, how do I get this on the output without, oh, wait. No, that's my mistake. Oops. This actually needs, because this needs to actually tie into this, I think. So how about that? Okay, that's what the issue is. Try that again. So in that case, just, just because we're gonna pipe this down and pipe this over this way. Okay. Yeah, the issue was I literally had it tied to the RAM. The switch here prevents that automatic feedback, as it were. All right, so then, all right, so where were we at? So this part here, and so let me do this. Because I don't have it on here. Let me add it. Constant equal EQ2 is 32, and constant not EQ2 is 33. Okay, we're gonna do an EQ2 and a not EQ2. All right, so now I just got to figure out this here. So if it's equal, and these are my two sources. So actually, if I just do 11 and 11, that actually may work, because that'll trigger this. Yeah, so if I do, but now here's the kicker. Actually, this is only, okay, so this here, since it's just it's not a source or destination trigger, this is just I mean, it's technically not pushing out. This is only pushing for the check. I can actually tie it to, I can tie that one directly to yellow and or green. Doesn't have to be both. So basically I could bring this yellow one down here and tie this into yellow, because 10 will only ever be a destination as far as but now 9's the same thing. 9 is actually a source. So actually that's the thing, is 8 will only ever be a destination because 8 is the trigger on load. 9, this is what we trigger to send out. So that there is going to be, that there's fine, but okay, so 9 has to also be tied to, let's say, yellow. So if I always do, as long as I which is argument 2, so as long as I for argument 1, and I mean, I don't want to do this. I could put something together like this. And you know what? If we're gonna do it, let's do it right. So let's go ahead and set this up. So I know, so 8 doesn't need 2 triggers, because 8 will only ever be a destination. 8 is just like out. It's only ever gonna take a single input in. So 8 just needs to have the one comparative argument, just like that. 10 is the same way, because 10 will only ever get a single input. So 9, which is the feed of the RAM, and 11, those two, we're gonna just to have things consistent, we'll set it up like this. And let's go ahead and just put it over here for a moment. And put it here for a moment. Okay, so with that being said, now, and then we have this double buffer here that ties into it. I was hoping this would be a little bit cleaner. Damn, can I get rid of this? No, I can't get rid of this TV. Well, I got plenty of room. Come on, I'm trying to move you up out of my way. Because frankly, I don't really care about you. All right, so we're gonna all right, so this is what we'll do. Okay. So it's not gonna be the prettiest, but it will work. Oops. Starters, move that down. All right, so we grab this, bring it over, and then get you out of the way. Bring you over. And just move you over, just give you a little space, just because. All right. So this because we're not doing a comparative. These are just going register buffers. So the way this would work, I'm just gonna get rid of these. Just remember 11 and 9. So the way this will work is we are going to have pretty much, actually this is not that difficult. This ties into that, and this ties into that. And I don't want, I just want the small thin line. Why are you giving me that large ass line? You know what? Whatever, I don't care. All right, so it'll be like that. Green will tap into this and then tap into this. And so as long as it's, because it's not going to feed back the system. So as long as one of these two plus up, and so, okay. What are you doing? All right, so put you like so, yellow. You are not where I want you to be. Okay, now you are. All right, so tie green together here. And then yellow will come up, over, and up. And you know what, take yellow up a little bit higher. All right, so yellow is going to come here and actually to there. Okay, so I can move you down 1. Green is going to come down and over like that. And technically, why not? we'll just have it tap down like this. All right. I mean, it is what it is. That should work. But can I clean this up any? Trying to think if I can or not. I mean, I can move this over a little bit, so to about there, and then I can move these over, and then I can move this over. So right about there, just because I don't want to get that too close to that, which then will allow me to move. I'm just trying to think if there's a easier way of. Well, I do have the byte one way. And what I could actually, I created something. No, so, because here's the deal. I will never activate both 9 and 11 at the same time. Because 11 is purely to do a register check. So I will never actually ever activate that at the same time. So in theory, what I could do, I still need this. I just don't need as many connectors down there. I can do something like this and that. Actually, let me move you over just a hair. I can do something like that. I take the green, feed it to that, and then I take the yellow, feed it to that, and then I basically take you guys, merge you, okay? Then I can get rid of this here. And basically, this is going to be 9. This is going to be 9. This is, and actually, now I only need one switch. Oops. Yeah, so I only need one switch now. Theoretically. A whole bunch of theory going on here. All right. So now, go ahead and move you down. Oh, no, hold on. Okay, let's do this. Move that like that. Draw a gray cable across for no apparent reason. So now I can do that. And then go ahead and do that. And then just because. I think if there's oh, you're off. I gotta move you up one. There you go. Or do I? No, I don't. You know what we have to move down? We have to move you and you down. There. Right now, and actually, aha! I can't put the byte one way up there because, so we're just gonna move you right there for a moment, because of the size of the component. Let's go ahead and move like so. Now, what happens? I keep on doing that. Move this down like so. Cool. Oh, I just noticed that this is off now. Move you down. Okay, there we go. Up. Go back there. Nope. You up. All right. So then rotate these so these are down. Go ahead and give me a connector here and here just so I can kill these for a moment. Okay, now we're gonna play Tetris. Actually, I don't need to play Tetris. I can just do it this way. Actually, there, let's play Tetris that way. You're supposed to be yellow. Actually, how about we just drag it there? Drag this here. All right, so now do this. Tie you to there. And then we can just do it that way. And we can bring you in. Actually, you know what we can do? We can move you. No, I'm trying to just grab the cable. Do that. There we go. And you know what? Go ahead and move you in one. Go ahead and move you in one. Not like it matters for that one, but still, just for consistency's sake. There. All right, so I think this will work. Because 9 and 11 are not used out here. 9 and 11, and so that's as far as opcode is concerned, no different opcode changes because we're pretty much just using immediates. All right, so in theory now, to unload the memory, well, actually, so hold on, so this one here does a null we're loading RAM, so we do a null immediate null, so 0 coming off of that input to 8. So this is taking in to RAM load. Okay, and then we're doing an immediate 1 because we want the number 1. It's going to do an add to reg load, or no, I'm sorry. You know what? Let's call it RR save. RAM register. So RR save to RR save. And so basically this is address, so RAM address increment. Actually, RAM address plus. We'll just do it that way, so it doesn't have to scroll. All right, then now this here was just a test. So this is just a test. Oops. No, just a test. Delete. All right. So this is just a test, so we can test out the jumps. So now we're going to do an equal, and what I can just do is it's going to be 11. So we do EQ2 equal to 11 11. So just put it in twice, or actually let's call it ramreg. So ramreg if they're equal, we go to unload. If they're not equal, so if that is not true, then it will go to the next line. Okay, now if they're not equal, it's gonna trigger this program counter to go to line 0, which is here, and it's gonna rinse and repeat this part here. Now obviously in the real thing, this line here will go away. So now if it is equal, we'll go from here to here. So now we need to reset. Okay, now if it is equal, we need to loop the reload. So actually we have two portions for this. Because we gotta reset the register back to 0. Which is what this does, but I don't want it to. Well, actually, you know what? I don't need. Well, yeah, I do need this. Do I need this? Yeah. I think here. Actually, do I need that? And the reason I'm saying that is, so for the sake of argument, let's say we didn't have this. It would check. Essentially is the RAM register the same as, now what's happening here is when it's doing this, it's basically triggering this to release or to flip these switches here. So it's going to take the register and compare it to that. If they're equal, technically, then it's going to not do anything at the top, and it will advance on to the next step. So what I could in theory do, because if it's equal, it's going to do the whatchamacallit. So what I could do in theory then is do this, put it up here. So immediate 1 null null to the ramreg. So that there's going to reset ramreg to 0. All right. Then actually, let's just, I don't need the 0. It's going to reset the ramreg. All right, then it's going to go into the unload portion. And so pretty much the unload portion is going to basically be an immediate Okay, well, actually, this it's going to be an immediate 9, so immediate RAM load, or null RAM load to out, and then it's going to do this, and then it's going to do this. No. Well, because I have to have it repeat. So in this case, it will, instead of doing load RAM, we'll go to unload. So because I need it to loop. But see, now here's a kicker. So we're gonna start off with 0. We're working our way up to 31. So 0 output, increment the address. It's gonna check. So we could do a 34, which is actually, you know what? Yeah, that's what we do. Okay, so we're going to do a 32, which is less than. So instead of not equal, so we're going to change. We're going to get rid of well, we're not going to get rid of it. We'll just add constant less than, when less than is 34. All right, so we're going to do a less than here. So if it'll do a less than comparison between this and this. Now this is okay. Now in this situation here, these have to be in the right position. So that means no. So if purple is less than blue, keep on going. All right, so now let me think about this here for a second. So 0, we do our load, we increment to 1, blah 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 blah. So on 30, so on step 30, we're less than, we go back around, we load, we've already incremented, so we load into 30, increment to 31, load. So now we're 31, turn around, load, this changes to 32. That will fail because 32 technically is not less than 32. So it's going to now then go to here, reset the RAM, and then so basically same process here. So now on the unload, all right, so let's say we're on step 30, unload 30, increment to 31, technically still less than, 31 is less than 32, unload 31, increment to 32. Yeah, so I think that'll work. All right, man, I think. All right, so, and we're gonna just do a test here. I'm gonna, well, no, I can't, so We're gonna do a test here, just to do a test. All right, so what happened? Okay, so all right, so okay, yeah, so we're loading. Hold on, it didn't load anything. I'm getting a 1 here. Oh, we're not doing a RAM load, we're doing a RAM save. Yeah, save. RAM reg. Loads down here. Okay. That explains it. Okay, so we got 1. We increment the counter here. Now this is the test for that didn't do what I was expecting it to do. That's because excuse me. Why? Why isn't 32 coming out off of this? Hold on here. Hold on. I'm doing an immediate 1. Oh wait, immediate 1 should be in this instance. That's my bad. This should be 32. And then or yeah. RAM this RAM register here. No, hold on. Yeah, so this is my value, and then I can just put some junk number here, so I can do 255. That's just a junk number. That won't trigger anything here. To 10. Okay, let's try that again, because 10 is my register. There we go. So now we're going to do a comparison. Why isn't this working? I'm pushing 11 in to both of them. Why is this not working? I should... Oh, son of a bitch, they're backwards. All right, my bad. Okay, let's try that again. Stop moving. Get off that. Whoop. Reset, damn it. What are we getting a conflict on? Oh, I'm getting a conflict on that. I'm getting 2 different values there. Shit. So I need a switch that turns on only if 11 or 9 come through there. No, I get that. All right. We'll fix that here in a second. We'll be back in just a moment. Okay, so I know what we need to do here. Go ahead and close you for a moment. All right, so what we're gonna do is move you down. Actually, let's just move you guys out of the way for the moment. And go ahead and get rid of this part for the moment. So, it doesn't matter, you know, if other numbers come down here and trigger these. But what I'm going to do is I'm going to essentially do something like this. So, he's going to check to see if these are equal. I'm just trying to figure out where I want to put this. So basically, it's going to check to see if both of these are equal. If it's equal, it's going to activate a switch that I will have on. Man, just trying to figure out a position, how I can potentially position this. And so technically I can get rid of one of the byte one ways. And I did mean to get rid of that switch. Grab that switch there. All right, so I really wish the damn enable was on the other side. So be it. The switch will go right here. All right, so if this is, and actually I don't need a byte one way now, because this essentially is a byte one way. So actually, now that I think about it, this here will trigger that. If this is good, then this green one here will come hit that, it will come hit that. Only if they're equal. Okay, because all right, so it's okay. So I understand why it failed on that. All right, so let's zoom out some more here. I'm trying to get the big picture of everything. Okay, so we load one, we increment the register. Okay, the register is bumped up to 32 now. Actually, let's let me stop and do this again. So there's okay, yeah. So like I said, it's because this is not equal, we're technically passing 0 down there, so it doesn't matter. We're at 32, so now we're going to do a test. Hold on. Boom, boom. Okay, we're at 32. All right, so now we're going to do, this is going to be a test if this is less than that. So where's this 32 coming from? Oh, because that 32 technically had to go through the add machine to get, okay. So, which is fine, no issues there. So now next test, we're doing a lesson check. So the lesson check is basically doing an immediate, or a less than, excuse me, ram reg. So I'm pushing 11 to both of these. They're the same. So we're pushing 11 to both of these. Not going to do anything down here on 9 because obviously it's 9, not 11. And so it goes here. We're pushing this here, but we're not doing a load, so it's not actually affecting anything. We're pushing 32 and 31 out. Or I'm sorry, we're pushing 32 and 32 out. So this has failed because 32 is not less than 32, which means it's going to pretend that that was the last load. So now it's going to go and it's going to reset the register back to 0. It didn't reset this. Immediate 1, null. Oh, because I'm doing ram reg. I need to do RR save. This has got to be RR save here. RR save. Okay. Restart. Okay, so we reset that to 1. Add the RAM block to the circuit and complete the level. You need to read all the bytes first. Well, I'm doing a test, so damn it. I just want. I would like just a test, but technically it should have. This should be. It's not letting me do a test to out. So I'm doing an immediate. Well, it's actually. Well, I mean, still doing my immediate null. So nothing there. RAM load, which is 9. So Okay. I am going to have to do dual switches here. Okay. You know what? So we're basically going to, yeah, because we're not going to do a immediate 9-9. We'll do a null 9 to kick the output. But this here is going to out. So actually, hold on. But what? But what? There may come a time where it wants me to take from the RAM and put it onto and have it added. So in hindsight, now that I'm thinking about it, instead of pushing this to here, I'm probably going to need to, tie it into one of these based on this. So basically this 9 switch here, which activates the push, depending on, okay, yeah, so yeah, let's go ahead and do that. Just think of what may be coming ahead. So all right, so let's go ahead and copy this. Well, 11's, I think 11's fine. The 11 checker is fine because that there is just, well, we still technically need 2 switches because I'm not merging these. So go ahead and give me another one of these. Now for this one here, I can technically merge them. But for 9, I'm going to need to have, oops. For 9, I'm going to need to have 2 separate, I don't know. Let me think here. All right, so just for the time being, go ahead and push. Go ahead and just do this for the time being, and then do that for the time being. All right, so you'll tie into that. You'll tie into that. This switch here can daisy chain on this switch, so that's not an issue. This switch here, however, has to be, it can tap into this, but it also has to do an independent push over here to put it onto one of these respective paths. All right, so let's get like I said, this one here, I can just daisy chain just like that. That there's going to be fine. Let's go ahead and move. Let's go ahead and move this down some. Actually, I can just move this. I can just move these up, I guess. Because I'm going to need. Let me think how I want to do this for a second. Okay. So each independent switch will trigger this, and then, as crazy as it sounds, it's going to come back this way. because damn it. All right, so we're gonna need a switch here, because when we're pushing 9, we won't be pushing the register. So I don't need to technically turn, because these should technically already be off. So if I do a switch, trying to think of how I want to do this. How do I want to do this? Actually, we can do it that way. Upside down. So do one there, and actually move these back just a little bit so I can have some room. All right, so this here is going to go away. This is going to tie into this, and this is going to tie into this. This will tie into that, and this will tie into that. So then, I gotta make sure here. So green is the tie to purple. So this guy here, you just go ahead and break that off for a moment. This guy here is going to tie into. All right, I gotta get myself some more room. Just to give my just to make it easier on what I'm thinking I'm trying to do here. Go ahead and put these buffers up higher. Okay. All right, so go ahead and bring these up higher again. And we may stagger these. So this switch here because I need both of these switches also to tap into this. All right, let me think how I want to do this. All right, so as far as this here is concerned, okay, I think I got an idea. All right, so let me go ahead and just disconnect this for a moment. All right, so we got this. Let me go ahead, because this is just a buffer of sorts. So this switch here will tap into this, and we'll tap into this. Then I'm going to move you down. This one here will tap into this, and tap into that. All right. Then this can tap it like that. That can go like that. This is green, so let me just mark. That's associated with green. That's associated with yellow. Let's make this that magenta color, because technically it's actually, yeah. All right, and then okay, I think and let me make these control cables gray. Just I think I keep on doing that. Make that control set gray so it doesn't confuse me, and make this one gray and do gray on that. And go ahead and do magenta there. Because this one here needs to be on this path for the comparison. Now, as far as the RAM output is concerned, we're doing this in the event that somewhere later on down the line, it's going to want me to take this RAM into a, and add it to something over here. So we have to do that. This switch here is just an activate to, no, this is actually a value. So that needs to be that color. That's control, common control, that's common control. I'm just color coding some stuff so I can, and technically these are all controls. All right. So, all right, I think this should work now. But let me take a look at the program. I'm gonna have to tweak this. So to do the unload for this exercise, we're going to do an immediate one null. So, and we'll put it onto the second argument path. As far as adding machine is concerned, adding machine will be fine because that's just a 128. So it'll go, so we're putting on the second path, which is this blue path here, which will ride the blue path all the way around to the adding machine. 0 will be on this line here. We'll hit that. Output will be triggered. So in theory, now it's going to fail the level, but if anything, I should see what you call it here. That's it's also, as far as this is concerned, let me see what let me put 8 onto the RAM. I don't know what that does for me as far as the watch is concerned. Okay, so it tells me the address and the value. Okay, cool. All right, so all right, let's see how this works out for me. All right, so step 1, we know it's good. I really wish this would follow automatically. So basically, because this is 0, our first value from input goes to 1. Cool. Now we're going to do our addition to increment the register. Then we're going, now this is just for testing purposes only. We increment this up to 32 so that we can basically do an unload. So we do a 32. Now we're doing the less than check. The less than check is going to say, yeah, and it's going to jump to, or it's going to continue on. So we're going to reset the RAM, and now we should see it's going to fail, and I'm fine with it failing. That's what I wanted to see. I just wanted to make sure that, and let's just check the path here. So yep, it's on this one here, and we're doing our add function. Okay, so that's just what I just wanted to validate that, the output. Now I'm going to go on the presumption here that this part here will work and this part here will work, because it won't take me back to them. We're just going to comment this out for now. All right, so let's see what happens here. So I'm just going to sit here and watch. So we should see values get up to here. So let's see what happens. It's bouncing between the two. The register's not loading, or okay, so it worked before, so that works fine. The increment works fine. They're taking a 1. Oh, you know why? I know why. The reason why is we're technically not pushing this out. We can push that out though. We have the capability. But it's got to be pushed out on number 1. So if we do a RAM reg, not a ream reg, we do that and then a 1. Okay, that's not right. That's hold on. Why? RAM reg is 11. Oh, why is 43 coming through there? Immediate RAM reg 10 load. Oh, hold on. I need to do immediate 2 on this one. That's why. Maybe. Conflict 1 and 32. Oh, that's another reason why, because this here, when I do an 11, that's another issue. It's pushing this out as well. Damn it. Crap. Wasn't thinking about that part. I totally forgot about that aspect. Because when I do a RAM reg, I'm pushing 32 out and 11. Don't know where 11 is coming from. Oh, wait. Immediate 1, which is that. So there's my 11. What if I do intermediate 2, 1 RAM reg? Just out of curiosity. So now I'm getting a conflict between this and what I'm pushing out here. Yeah, see, my problem is the way I have 11 set up. So, couple things I can do here, maybe. Damn it. Either A, I create 12 to check the register and do another set of switches here. And 12 would be essentially what releases this along with triggering this. I think that's what we may have to do. Essentially what we would do is have a set of switches, a pair of switches, you know, just another pair. We put a bit stopper, you know, bit one way here, and we have 12 apply voltage here. No, because that would activate that switch. Actually, no. So hold on. God bless. I know what the issue is. I just gotta. So yeah, we're gonna have to do a 12, I think, for the register check. I'm okay with that. It just now I gotta move. Okay, actually, not that big a deal. Just do this. Slide that shit down. See, now the problem's not there anymore. See, it's up there. All right. So what we're going to do here is we're going to do another pair of switches here. So just go ahead and draw a gray cable across them. All right. So go ahead and copy this, paste it, and we can put it right there. This is going to be 12. All right, so now, how is this going to work? All right, so 12's only function is essentially, well, okay, so since 11 is going to be the load register and not the register check, I can get rid of this and get rid of this. Let's go ahead and just get rid of this for the time being. We can move this up just to kind of get it out of the way for me to put some stuff around. Okay, so now 12, just like 11, both 12 and 11 are going to have to activate this switch here. So this here, I'm basically going to have to do something similar to this. So we're going to have to come up and get 2 of these, and we can actually do it this way, I think. Tie that, tie that into that, and oops, and then do something like that. All right, so then 11, I think I can get rid of this now. No, I need that. Do I need that? And why did you change back to orange? You bastards, I changed all you guys to gray. Sorry, I'm just being anal with my colors. Well, I know I changed you to gray. You're a new one that I copied from. Why you weren't gray, I don't know. All right, and this is a control line as well, but I can leave that alone. All right, so why do I have this here? I don't need that on 11. Because 11 is now just going to activate that. No, yeah, because if 12 comes through and pushes the signal back this way, not that big a deal. Because it's not, you know, so I don't need that. The reason we have it here is because I don't need a feedback coming, because one of these is load and one of these is save for the RAM, so I don't want it coming back that way. But as far as this is concerned, all right, so I don't see a need for this. All right, so then for 12, basically tie into this. You will tie into that. So this will be the register check. This will also, we'll need this here. The reason why we're going to need that there, actually that's the only one I need, because this one can tie into this. And actually I can go ahead and move these down, and then I can actually, no, I don't have, I'll just leave those where it is. All right, so when 11 is activated, it'll activate this push and turn on the switch to output onto purple, which is the immediate 1 channel. And it only goes to immediate 1, which is fine. When I do my register check, we'll be doing a signal 12. 12 will activate this switch so 32 can go out, and it'll go through here, hit that switch and put that out. All right, yeah, so I only need the blocker there so I don't activate this. All right, so now with that said, go ahead and add our new code. So that's all right, so let's see here. Now, 11 is going to be RR load. Right? And then RR check will be 12. All right, so when we want to reset the register, no, it's not reset. Yeah, well, when we want to increment the register, on the increment portion of it, we need to do an RR load. You know, it'll be immediate 2. Actually, let me see here. No, immediate 2, because 2 is going to tap into here. So immediate 2. No. Wait, hold on. Yeah, immediate 2. So immediate 2, RR something or other 1. So, oh, okay. So, okay, so immediate 2. This is going to be an RR load. 1 RR save. And then this will be RR check, RR check. And then this here again will be RR check, RR check. And then here, it's going to be identical to this. That's the increment. This here should still work because RR save is set to 10. All right, I think this is what we want. Let's find out. All right, so let's get down here. Step 1. We got our value. Check. Step 2, this becomes 1. Check. Step 3, we check. Okay, so we're setting 1, 32. It's going to fail. No, this is going to pass. It is less. So we're pushing 0. There's my 0 coming across. Is that a 0? No, that's an 8. But here comes 0 right here. And it reset the counter to 0. So it's going to basically go back here. So we should see 33 because that's what we've been seeing in the past. Or why 30? Was it 34? Is that 34 before or after an add? All right, where's this 1 coming from? Where? Okay, so that's wrong. Why is that switch activated? Okay, that's going to be an issue. It's not an issue because this. Okay, no, that. I know exactly what's causing this. Move this up. And you're going to get rid of this and go ahead and actually bring this over. So what the issue is, I didn't even take that into account. I will now though. So we need a byte buffer here to prevent this from triggering the switch. It can trigger this because we need this to push down here, but we don't want to activate the switch unless 11 or 12 are called. Okay. I'm good on that. I'm okay with that. All right, so let's start again. All right, so now we should get 33 on our next pass. 33, good. So now increments to 2, good. Why are we passing 1 across that? Oh, no, because we're pushing 1 out. Because that has to go into the add machine and then 2 comes in. So no, we're good on that. All right, so I'm going to breakpoint to that point. So it's loading. Okay, so now Okay, we've got all 32. And we reset the register. And it said load 32 times, or I think. All right. I can take that breakpoint off now. Now, here's the thing is, right now we're going on the, I mean, we've got it set up. Right now we've got it set up with this here for our load limit. So if this changes later on, if they say, okay, you gotta, base your load limit on, some value, then we'll probably end up doing, will be a fun one, is we'll be putting a register here, but it was successful. I don't know what this means, but I'm okay. All right, so what are we working on now? In order to cut spending, it has been decided to change the queuing system at public offices so that fewer people will go. Instead of first come, first serve, we are implementing last come, first serve policy. Think of it like a stack of numbered slips, whereas the citizens either put a slip on top called push, or the bureaucrats take one off the top. With a stack called pop. We want you to implement, so basically, this is the opposite of the FIFO system, the first in, first out. This is going to be the first in, last out system. Or last in, first out, LIFO. Each tick, the inputs will either push or pop. Hold on. If it is push, store the value on top of the stack. When it is pop, remove that value. Okay. So, that's not what I was thinking. I thought we were going to have to do something with the computer. Okay. So these are just byte inputs, so don't pop, don't push. Oh, Jesus. We're supposed to store this. Okay. I mean, is it not a counter? So let's read this again. Since either put it, so each tick, the input will either signal push or pop. If it is push, store the value. When it is pop, remove that value from the stack and output it. Now, when you say stack, what do you mean by stack? Because one thing I'm thinking of here is this, and that. I mean, that's what I'm initially thinking. I know this is wrong. Yeah, okay. So I've got to store these values. A single register is not going to do it because the register, okay. Okay. Ooh. And you're not giving me much space here though. So, I mean, we're going to deal with something like this. Oh man. I think. Now what did, okay. This may be even a more wild and crazy idea. Oops. All right, so I kind of get what they're asking for. Kinda, sorta, kinda. I have no idea if what I'm about to do is correct. All right, so what we're gonna do pop means remove. Let me see what this does. Okay, because it wanted me to remove the last one. All right. Oh, and also the fact that I'm not actually got an output hooked up doesn't help anything. All right, so how does this? Oh wait, I think I got an idea. Maybe. Just maybe. All right, let me go and clear these off. Give me. I mean, we can technically use a register for this, I think. So this here will feed this. This here will also feed this. This will feed that, right? That's the address, yep. This will feed that. And feed that. This will feed this and feed that. So I'm setting my trigger to load, and I'm setting the value that I want to take from, or the address where I want to take from. Why didn't that? I'm confused. So now the next thing it wants me to do is this. I'm pushing 34 here. Oh, but one is okay. I see what's going on here. I see what's going on here. Okay, so it's time for me to grab another drink and think about this. I've got an idea. We'll see how it goes. So be back in a moment. All right, I know what's going on here. So what's going on here is this thing here is passing a 0. I need, there it is, Mux, good. All right, so what we're going to do here is make this even more spaghetti-like. But I'm presuming that once this level is done, it's going to give me a component for this. So that goes there. It's still, actually, hold on, wait. I still need this to go up here. And then the default, let me see here, the default. All right, so then this control line comes here. All right, we'll clean it up just a bit, just so I can follow what's going on here. Where the hell is this going? That's not going anywhere. All right. No, I'm trying to move you. Oh, wrong button. There you go. And okay. So in my mind, this works. Like everything else on this game. Because right now we're pushing, which means we're loading into the RAM. And so we're storing what we just loaded. And by default, nope. I have my inputs backwards. All right, so this actually goes to this. This actually goes to that. Okay, let's try this again. So So, because by default, this one here is on. But when we go to pop, it'll change the source to that. So 33, 34. Now it's gonna want me to pull 34, which I did. 81 is being ignored. Pop off value 35 or 33. Oh, but 33 is already gone. All right. This is gonna be a little bit more tricky than I thought. Damn it. So basically, we're gonna have to do a counter, add, subtract type deal into a register. Oh, man, this is gonna be a lot more. Okay, let's go to wipe all these out. All right, so here, you know what? Here, you move up here, and you move over here, because you don't need to be. I'll just put you that big just so I can see what's actually leaving. All right, so we're gonna have to have a counter. Where's my counter at? All right, and so on each tick, excuse me, the counter is either, and let me do an add. No, actually, I don't need an add. I need a subtract. And so give me a neg. Where's my neg? All right. And we're gonna do a constant of 1. All right, and then but how is this? So by default, the counter is going to give me my address. All right, and then if triggered by the pop, which is the pull, we're going to, well, now here's the thing is, I still think I need to go into a register. Just because of, I guess, the tick delay that I need. Where's my register at? I kind of still think I need to do this. Oops. And so the counter will feed the register a number. And then I'm gonna move you guys up just for the moment. So on a push, which is this guy here, that will trigger a load. And technically, it's also going to trigger an unload. So, you know, let me move this just for the sake of argument, or for a moment. So a push will load the register. No, wait. Hold on. No, yeah. So the push will do that and also do that. And I know it's failing right now because I'm just doing a test here. So let me see here. The 0. But now see, we're starting. We got a delay here, so it's gonna. It's. Well, no, that's not sending us. So it is. So we got a delay of sorts here. Oh, you know why? Well, no, I mean we still have a delay, but we also need to do that. But we still got a delay here on the counter, because. All right, so that's too much of a delay. All right, so what if we have this go here? Now, issue on this is we're going to get a conflict right there, which I knew we were going to get conflict on that. All right, let me think here, because I need a counter. All right, so by default, you know, first one's going to be 0. Well, okay, so let's get rid of the counter. Because, all right, so let's do, as crazy as this is, let's do this. So on a push, this is that's okay, so that's our address. Save value is going to be this. The save value is going to basically be, stop it. I really wish those symbols would get out of here. All right, so give me, we'll do the mux again. Oops. Can I do this? Will that? Okay, cool. That's fine. You know what, here. Let's move you, let's do you like this. Just so I can, yeah, get out of the way. We're gonna put this and here. Put you here, put you there. You will tie back to there. Actually, no. I actually want you, because you're gonna tie to the mux. So we'll put you like so. You're gonna go up top. You'll tap into that. That'll go there. No. Because okay, so we'll do the subtraction here then, because Well, it all depends on which one we want to be active on the mux. So the default on the mux is the bottom, I think. I can't look at the, so yeah, no, sorry. So what we can do is we'll have the push be, because it's not, you're not going to push and pop at the same time. So we'll have the push, I mean, we'll have the push be the trigger for the mux. Okay. Now, as far as the save and load into the register, okay, well, let's get to that in a minute. Now, for this, which is going to be triggered by, okay, so we need connection here. All right, so that will feed this, and then this is going to go into the mux. As crazy as that is. All right. So and then both the push and pop should do a load and save in the register. But we need to do this with this so that it doesn't trigger the mux. So we do this into that. And I think technically I can do this. And then we take this. And then the push loads this guy here. This is where it's going to get spaghettied. All right, what's that do? Okay, so no, I gotta, because that's I need to put a stopper there as well. Okay, let's try it again. Okay, so reset. Okay, so we got one. It didn't advance. Why didn't it advance? Shouldn't 0 plus 1 give me 1? Last time I checked. Oh, you know why? That's not an add, that's an and. Let's try using the proper thing here. Wow. Add. My bad. Oops. All right. So let me. I was wondering why something looked off on that. It was like it seems too small. All right. So. All right. So. All right, there we go. And then for this one here, go ahead and get rid of that for the moment. Technically, that'll work. All right, but fine. All right. Hold on, what? We're adding into the carry. We don't want to add to the carry. All right. There. All right, so now, good. Good. So far, so good. Okay, so now, so I guess, okay. So when it goes to a pop, we need to, well, we don't want to stop the flow. I guess, okay, I have an idea. Another wild and crazy idea here. Let's go ahead and move this over some. As if this wasn't complicated enough as it was. And I'm probably making this more complicated than it needs to be. So hold on here. So when it's on, I'm trying to click on this. So when, all right, so this mux here is tied to that. So when that turns green, we're taking input 2. All right. So on this one here, when this turns green, I want to take input 2. And then, all right, time to move you up, buddy, and rotate you around. Just to give me some more room here. This is so goofy. All right, so I'm gonna take you, pipe you into that, and then we need to tap into let me look at the mux. Okay. Get rid of this and do it that way. Okay. Again, so when this is green, it will use input 2, which is the bottom. All right. So I think this is an on-off thing, dumbass. This has no effect on what should we do? Oh, no, okay. No. My bad. I don't know why I hooked it up to that. I meant to hook you up to that. Okay. Okay, no, that's fine, right? Okay, yep. Okay, now, cool. I'm flabbergasted, but okay, can I clean this up any? I mean, you gave me a new component, so I technically don't need to clean this up because you're actually giving me the clean component. You know what? Fuck it. You gave me the clean component. I'll take the clean component. But now we're gonna have to put this on here. In this level, you are supposed to add the stack to your computer. When the input is 0, you should pop, which is load. No, pop is load, push is unload, or pop is save, push is load. However you want to look at it. So in the 0, you should load or save the value of this. No. Wait. God bless it. I just did this and I can't remember. Push. So pop off, push on, or push in, pop out. Okay. So push is save, pop is load. All right. So when it's 0, you should pop a value off the stack and output it. When the input is not 0, you should push it onto the stack. All right. So you've given me the programs. That's programs. Where the hell is this pop shit at? RAM, stack. Okay. Here's the one question. When what value is 0? You're not, oh, you're saying, oh, wait, when the but again, when, okay, wait. I get it. When input is 0, now isn't this, so how is this going to work in the big picture of things? So we got our input and we got our pop or push triggers. Tracking, got our output, tracking. So my input is going to determine, so and also here's the other question. All right, so when the input down here is 0, I should pull a stack off here. When it's not 0, then whatever the input is, I put into here. Okay, so I guess we'll make you location 12. No, I can't make you location 12 because I got 12 up here. 12 is doing that, right? So this will be location 13. Because so let me do something here. Load register and 12 was check register. 13 will be stack. And All right, so 13 will be a stack that we will essentially basically tie into this on, which that's easy enough. All right, so if we have so I guess the program on this would be immediate immediate 12. No. Immediate 1. Null 7 to 13. But now here's the thing is, but then I gotta do a check on the value. And all right, so we're gonna need 2 checkers here. So one checker will be for 0. And another checker will be not 0. So actually, because we don't know about positive or negative numbers in this, so we have to go on the presumption that there could be positive or negative. So a not is the best option in this case. So go ahead, give me 2 constants. This constant can literally tap into both of them. And so actually what we'll do, move you down, because this way you can go to that, like so. Oh, sorry, I had to sneeze. All right, so we're pushing a 0 to this, and then we're gonna have to have a technically a mux could work on this. No. All right, so if it equals 0, okay, so again, equals 0, we pop. Which one's pop again? Okay, let's flip this around. Just because of the, so if it equals 0, it pops it. Doesn't equal 0, it doesn't pop it. Let's go ahead and actually let me move these up a little bit and kind of get you guys just a little closer. I think that's as close as I can get. Oops. I mean, I can do that, but no, we'll just have it be there. Go ahead, go up just like one more. Actually, go up just, that's good enough. Now go up so that this one here. All right, so that's going to be that one. All right, so there's my push and pop trigger that is going to be fed via this. So you know what, now I'm going to run 2 cables just because. All right, so that's going to do my check here. Now what? That's the $10,000 question. So now it says output. What output do we put it on? 1 or 2? That's gonna be a excuse me. That's gonna be a question for us. I'm also going to need something here, and you know what? We'll do that here. Actually, we're going to do another equal sign because this should only trigger on a. Okay, so this is actually where my where these two would come into play. So we're gonna do basically a pair of switches that are gonna do God bless. So actually, hold on here. All right, so, man. We're gonna put a switch here. That switch is gonna be triggered by this here. Or that's gonna be triggered by, let's actually, I can get rid of this here. Go ahead and give me a copy of these. All right, and go ahead and how do I want to do this? Put you right there for now. So this here, come down and feed that. This is going to be, I said 13. I'm running out of. I'm running out. Well, I'm not. Yeah, because I don't want to tap into this because 16. Well, 16 is my shifting. I would really love not to tap into 16. So I mean, I'm sure there's another way of doing all this, and I'm sure I could redo 16 so that maybe it was a 30, you know, so like 32 options. It does this because the 32s, it's let me see here. So it's 32 through 37, so that would be 5 and 1. So I could technically have I could do a somewhat of a complicated OR and NAND NOR XOR XNOR, all those things, and basically tap into 32 with a combination of, you know, either, you know, as long as it goes up to 37. So let me just see here. 37 is so as long as so basically do it so in a way, if it sees that, it ignores, it doesn't trigger that, and if it sees that, it doesn't trigger that. But if it sees, you know, 37, you know, we'll cross that bridge if we get there. All right, so this is going to then basically pass the signal to this switch, which will then allow this to check. So if we get a 13, it's then going to look at the input. So if we do so how would this work? Because it needs a pull from the input. So you don't want to do a copy. So what would be well, then that's the thing is, if you did a 13.7, for example, you know, let's say you did a 0, 13.7. The 0 is going to try to have it do math. Well, you do a 13. This here is not actually going to release anything. So you do a 13.7, a 0, 13.7, let's say. If input is 0, then this will pick up that 0, and then it'll push something to output, like. But if input is not 0, we're supposed to store that, right? When input is not 0, you should push it onto the stack. Yeah. So oh man. Well, here's the thing is, input's going to go to the add machine. Excuse me. The input's going to go to the add machine. So the question is, do I want to, instead of checking this, do I literally want to pull from input and check? And then if we do a 13.7, we check input. And if inputs, if we do a 13.7, which triggers this to look for 0 or not 0 for the stack. If it's 0, if input itself, the raw number is 0, then we basically take this and put it on. Yeah. But problem with tying this in is I can't do a direct tie to this. But it's not saying about doing any sort of manipulation. That when the input is 0, you should pop a value off the stack and output it. When the input is not 0. Okay, so in this instance, we're not actually tying to input. So output here, we can tie the output. Okay. But as far as the stack input is concerned, that's going to be handled directly by this. So we bring input over, run input up, do our input check here. Now, this is going to give me, when it's not 0, we want to put something in here. So, where's my switch at? When it's not 0, as weird as this seems, we're going to take this, plug it into that, tied to that switch there. All right. But now, here's the big question. So, we'll get a trigger on 13 to activate that. Got it. So what we do, a immediate think here, or would we want to put this into, or would we want to tie this to the 32 segment? Because the 32 segment will, the 32 segment will prevent this from going off. So if we did an opcode 38, let's say, .38 won't do anything. Well, let me see here. What's my toggle on this? Well, 38 is a toggle for that. So that's just gonna toggle the output. So 38 would toggle orange and push it to the counter. However, 38, no, but anything with 32 will trigger this, and the default is 0 equals 0. So if and by default, this is 0 equals 0. So I swear to God, I put a note on this, but it's not there anymore. That's okay, because as long as I got one of the notes, I'm okay. All right, so we do a 13. Well, the 13 here is not an issue. So the 13 and the 7, the 7 is going to be needed to have this do an output. What's my disable on this? My disable on this is whatever that number is, 24. Oh, what about that? What if we do opcode 24? If I do 24, that is my disable signal for this. So if we do 24, 13, 7, but now here's the kicker. So that will enable this to be checked. The 7 will trigger this. But as far as the output's concerned, I only want to output it if this, so am I going to need to run this all the way over here? Because it's saying push it straight to output. It didn't say stored in a register. And I only want to do that because I don't want to, I can't go through the if process. All right, so for the sake of argument, let's take this. We need to put a blocker on it because I don't want a normal 7 to trigger an offload here. So we're just going to test this out here. So I do a 24 or wait, yeah, 24, 13, 7. Okay. We'll see what happens here. Actually, so what we'll do is, right, so actually, so this last number here, we can just do another 13. I can't leave it blank. So we do a 24, 13, 7, 13. Yeah, let's go ahead and try that. So 24, 13, 7, 13. I'm trying to see all of this here. All right, so it's not 0. Whoa, what in the hell is going on there? Well, that's definitely not what I was expecting to see. So 24, 13, and 7. So, you know, we're hitting our 13 here, so we're passing, turning on the switch, passing 0. Hold on. That's not what is supposed to happen. I'm real curious where these other numbers are coming from. Hold on. Oh, you know what? This is how this works. I don't need this. Okay. Basically, okay, let's go ahead and slide it back some. All right. Actually, what it is, go ahead and slide that over, and go ahead and slide that like so. And you know what, you can what can you do? You can put a weird cable across that for no apparent reason. Go ahead and slide this closer to Just go ahead and do that. That's fine. All right, now go ahead and do that. And you know what? What? Go ahead and just because move this to there. We're going to put an inverter on this one, right? No, that's equal 0. Wait. Equal 0 push, doesn't equal 0 load. No, I see. I don't want to do that though, because that's going to trigger this to load on every input. So no, I don't want to do it that way. I'm not liking what I'm about to do here. Like I said, don't know what their plan is for negative numbers. So what I'm tempted to do is, although I don't think we've actually done any sign stuff on this, because the neg won't work here. Or will it? No. Let me take a look at something. Let me look at this here real quick in the if checker. Check. So not equal to is 33, so that's going to be that. Hold on. Well, we need 32, so go ahead and trigger 32, okay? And then that. And then the 33. So then this is our not equal to, so. All right, so how are we doing our not equal to? Yeah, so. Okay, so what it is, I got to do a switch there. All right. Okay. So I see what I see what I need to do here. As wild and crazy as this shit is. Well, no, actually. So what we do is we get rid of this switch and basically just put it here and here. Right? Yeah, I think. Yeah, so we basically we do the inverter, but we have two switches. Yeah, no, what are you doing? All right, so because both of these will never be active at the same time. Because if it is equal to 0, then this will turn green. And technically this will turn green as well. But this will invert and not pass anything. As far as the signal. If this isn't green, then this will be green. Okay, actually, so Hold on. Do I need 2 checks? Or can I just do 1 check and then... No, you know what? Just be on the safe side. We're gonna do it this way. Now these two can tie into one another. That's not an issue, because they will only activate if a 13 comes down. All right, so now let's see what this does. So our program that we're going to do, we said 24 is going to be the opcode for stack, or for doing a stack. So it's going to have to be a 2413, which is odd, but that's the way we're going to do it. Because 24 is not used by anything else opcode wise other than turning off the adding machine. So let's see what this does. All right, so we loaded 219 into this. I am curious where 182 is coming from. Where is the phase shifter? Why is the phase shifter on? Why is the phase shifter on? Because the phase shifter should only turn on when we have a 16 coming into it. 16 coming into it on what channel? Oh, you know why? Because technically 24 has a 16 on it. All right, so I need to tweak the phase shifter to only have 16 and nothing else. So let's go ahead and do this. Let me go ahead and move this out a bit just so I can have some room to do some stuff here. So I want it only with the 16. So for that, we're gonna put an do not that. We're gonna do an and, a normal and. We're gonna put an inverter. Okay, let me move this and a little bit more then. We're gonna put an inverter here. So this way, because we may have to tweak this later on as well. All right, go ahead and move this back. And can we move this back any? Just kind of keep the components semi close together. Hopefully that didn't mess up the schematic here. Let's see. Okay, that's okay. All right, so now let's try that again. All right, so good. The phase shifter is not activating. All right, so we loaded. Okay, let's start again. The 219, good. Next count values. Next counter value is. Jesus. Oh, you know why? Because I don't have anything in my instructions. So that's we're just gonna repeat this a whole bunch of times because I just want to see what's going to happen here. So now we should have pushed the 94 out, which technically we did. All right. Now I don't know how many tests it's gonna want to do. So essentially, we're just gonna create a loop here. So we're gonna do an immediate one with the value of null, or it'll be immediate 1 0, and then actually do an immediate 2 or immediate 12. Hold on. To push a value to push a value to the counter, we need to do a 6. Okay, so immediate 006. That should do it. That should reset the counter to 6. So double immediate, so 006. I think that should do it. Right? God damn it, I'm trying to scroll the page. So it's technically working. I don't know if it's going to work in the long run, but well, it works for now. All right, last one for this session, maybe. Let's see. Sometimes it's useful to reuse a section of code. We call these section functions jumps. Or to implement one, you can use jump it. To implement this reuse, one can jump to the beginning of the function and jump back in at the end of the function. We call jumping the function calling and then return. But for this section of code to actually be reusable, the return jump will have to be able to return to different locations depending on where we call the function from. We could save the counter value to register before jumping to the function and use this value in returning. However, if done this way, the function will not be able to call another function since this would overwrite the original address. Say function A calls function B, B calls function C. When we want to return from C, we only need the return address for B, and in B, we only need the return address in general, regardless of where the function looks. This is exactly okay. In this level, you are tasked with implementing function call and return with the call and ret instructions. Note that when returning from a function, you should jump to the address that came after the call instruction. Otherwise, you'll end up with an infinite loop. Call instruction has to do with the following. And that. Okay, you know what? We're gonna hold off on this one here because I have an idea of part of what's gonna happen, and that's I'm gonna have to create a program to pull something from the input, do something this, call this, store a jump location into here so it knows where to go back to, or multiple ones, so A, B, C, D, do whatever, and then depending on what happens, we call it back and this and that. So we're gonna we'll pursue that later on. So I think that is where we will call it for now, and I'll pick this up later on. Until next time.